After opening the gsas software, you need to import your data. It should be in raw format. If you import excel and origin, after that saving txt, sometimes it is not working. So the main subject is here, so you should use the main raw data obtained from the devices. So when you go to import, there is different subtitles. Now we will focus on powder data export. There's some device names which you want to directly export. So our device system is Rigaku. So it was Rigaku TXT exported. Or if you don't know anything, you can jump to gas format. You can also try to open in the program. So we know that our data is Rigaku. Okay. When you click here, my PC is Turkish, so sometimes it's showing some Turkish words, so don't worry about it. Now we should find our data, and I will try to open something here. This is the last composition which I tried to make some fittings. Let's choose one of them. Sometimes the background of data, okay, I will start again. Cancel, import, powder data, go to Vigaco TXT, and I would choose which we want to use. Sometimes when you get the data from the devices, the background is very not clear. So sometimes I am making smoothing before the importing here. This is another issue. Okay, I open some smoothed data and cancel. Here is the which the system you are using. We generally use default for copper key alpha lab data. Okay. Yeah. But if you want to change, you can also change. It's not clean. Ali okunuyor mu? Evet. Okay. So we are choosing default for copper key alpha lab data. Okay. Okay. Now you can see the experimental diffraction data here. Now, second part, we need to import zip file. So to make this gsas analysis, there's two options. One is you can use zip file. Another one is you can create one zip file. Second one is difficult. You should know the position of the atoms. You should know the EBC parameters. You need a lot of information. If you know reference data, reference zip file, you can easily make fitting. Okay.
Okay, from where you can get this is the references from the literature or what?
Yeah, I will show. Okay, we can stop here. Normally, I am using Match. I will open this one. This is there was free version for
So-
90 days. After that, you need this license. So I have a license. So you can export data to here. I will show you.
So my question is, did it work with internet or without internet?
This is
It is working without internet. Let's open one data. He is asking the wavelength something. You say click here, okay. And then you can jump here and toggle, let's say some elements. I am arbitrarily choosing. After that, you can click here for the making the best fitting materials. Wait. He can find some faces and you can choose it. I am arbitrarily put something here so the face is not fitting exactly. Let's say this is this material. When I click the space, it is coming here. Okay. When you click the right click, you can export entire data as a zip file. This is one choice. Another choice, if you don't have this program,
Yes.
but you know what is your faces, you will go to internet and write ladder, wait, open crystallography, database. Base. And you should go this web page and click search. And let's say we have sodium metal, manganese. I am again arbitrarily writing here, and oxygen. So we know that our phases four elements. This is the distinction of phases. It means your phase should be just four elements, not much, not more, not less. It is easy to find something. When you click the send, you find one phases. Did you see P63 MMC, which is P2
Yes,
type
yes, yes.
structure? You can download this one and you can continue to work this one.
Okay, but according to your experience, which one is a good methods for front?
Both of them is same. If you know the
Okay.
zip file, if you have zip file, you don't need anything.
Okay.
If you have mesh program, if and the phase is unknown phase, you
Okay.
can go there. But if you know this is P2 type, just download this one, work here.
Okay.
So when you check here, you can see this materials including iron, manganese, sodium.
Okay.
Maybe you can substitute manganese with nickel. I will show you how you made it. Okay. So we will close here, and was our faces. Okay, we will close. Now we will import zip file. We can download somewhere and we can obtain somewhere, no problem. Go to from zip file, face. Previously we focused on powder data, now we are focused on face.
Okay.
Face from zip file. There's a lot of different option, but I just use here, so I should explain here. Maybe the other is also useful. When I click here, previously I downloaded here. Let's choose one of them. Which one I am using, I am not sure. Uh, Reflection. I think it was R3M. It should be this one. Why I put some stupid AIS name? I am not sure. Let's check it. When you click here, he is asking, should I read or something? You can click yes. He says sometimes error to names, sometimes the CIF during the production of CIF file, they are using the element's name with small letters. Uh, Look here, he says LI. There is a problem. No problem. Just click OK.
Okay.
It is written what is the say with CIF file. We don't care about it. We will change later. Click OK. And here is important. You should also click here. If you don't click here, there is no relationship with experimental data and fitting data. After that, say OK. Now we are ready. We added faces here. Face name is not important because we will change it. And OK. Before the starting, you should, if you make some change in your structure, you should play here. Okay. I will go more. Normally, sodium position is this one 0.333, 0.66 something. This is sodium position. If your sample doesn't have lithium, let's say we produce sodium, mangan, iron oxide, we didn't make the doping, you can click here and delete. Okay, here's fraction now. We have sodium 1. The all fraction on chemical formula, it is 1. Okay, this is this 3 for transition metal position. It means 0, 0, 0. There is one transition metal position in the structure, one sodium position here, and one oxygen position. Let's say our sample just including sodium manganese metal, and we also delete this one. Okay, you can double click here. Yes. Choose which element you wanted it with valence state. Let's say manganese plus 3. So the fraction should be again sodium manganese 2 should be 1 because we deleted everything. Now it is almost ready. We don't care about the other section. Later we can make refine. Okay. Come here. If you want to limit the fitting area, you can change here. Normally, standard value is 3 to 80. Okay. I don't care about here. If you want to delete, let's say there is no pick here, and you don't want to here, you can change here. Second one, background. Background is related to your data properties. You can see that there is some fluorescence effect in our sample, so background is going up. Not there is no linear. If we have uh, better data, it should be go linear. So this is device properties. If we don't have monochromator, you can obtain this kind of data. Okay. So we cannot do anything, but we should find the best fitting uh, background. So they are using some different model with different parameters. So if you want, now he says that there is three different parameters for the fitting of the background. We can increase, let's say, 9. So should click refine, go to calculate, and click to refine. He will ask for the first try, you should save it. Okay. First, I will put here, open one file, write try. Okay. Double click, go inside the file, and the name is also, let's say, try. And then save it. He fitted for the first time, and the RW value is around 10. You can click OK. You can see it is fitting not good, but it is not bad. Okay, this can be all time can stop refine. We don't care about it. Go to instrument parameters. First, you should choose here. It should be again copper Q alpha. If you use, say, let's say molybdenum tube and another type of chromium tube, you can change here. But generally in the lab, we are using copper. Okay. Yes. After that, we can fit some parameters here. We will jump another section, sample parameters. If you make one fitting, one composition, you should click here. If you think that your sample have two different phases, you unclick here and make here one. So it means total phase histogram scale should be equal to one to calculate a ratio of the phases. Okay, now we can just click one phases, so it can stop there. We should first fit the sample displacement. It is due to operator or when you put your sample inside the sample home, actually the sample holder, if you make smooth on the surface, or if you put some samples which in the area less than what you want to put there, or it is more. This reason, or there is some misalignment or sample holder calibration error, you should first make the sample displacement. I think. Okay. When you click here, you don't need to calculate, go refine. This is one choice, or Control R is the easy way. Okay. And you can see it is changed, and several times we can try it. It is starting to decrease. So it is 1.2, 1.1, going down. Okay, it can stop there. Now we'll jump up again. Instrumental parameters. We just fit U, Y, and W. First click U. Started to fit. You see, green was fitting data. The blue one is the experimental data. Started to fit, and the value going started to going down. Let's make 2 times. After that, unclick this one. Click the second way data. Yes. Did you see it started to get put? And unclick this one. Click this. The other one. So just make 2 times. Now we obtain some data, and I went to make together. Maybe it is better. Sometimes it is better. Did you see? And yes. Okay. So to see the peak position and fitting data, you can click here and come here. Yeah, when you check here, the green one is fitting data, the other is blue one is our data, and there is some not good fitting in this section, and here is better. it start to fit. This is unwanted peaks here. There's unwanted faces also here. Here is better than the others, so we will go better. Now the background and the peak position is okay. We didn't start yet the face fitting. So I will come here, click the faces. First, come to general. There is some another options. Come to general and click define unit cell. After that, yeah, here is important. Until now, we just make the calibration of data, and this is not directly related to phase properties. Now we started to fitting of our data. We see that yes, the gsas, the zip file was fitting our data, and we started to fitting the rw value goes to 10 below 10, so it is okay. Let's continue to make fitting of our data, our faces. We clicked here, control r. It is around 6. Now it is better. Did you see?
Yes.
And the value is going down. Just several times I did. Now we will come the data later. I will jump the atoms. Now there is difference. When you double click the refine, you will see the difference options: F fittings, X fittings, U fittings. We X related to position of the atoms. We should try to make this one. You can also look the X, Y, and Z values: 0, 0, 0, 0, 0, 0 something, and the other is different. When you make the fitting, it is going some stupid arbitrary value. There was something is error. Okay, sometimes it gives good fitting, but it is not physical meaning. Yes, it's going down again, but it is not good. Okay, now I want to make one by one. When you click the empty area, choose the X. Okay, after that I will jump to F. I also check the RW line. It is going down. Now it is okay. So it changed the 0.9. Normally we choose 1. It means according to fitting program, it is going down. So you can also use here, or you don't care about it. It just depends what you want. We can now start again X. Again, something was changed. And go to F. Now it is better. The oxygen is very important.
Yes.
X and F value is very important. Efendim? İyi günler. Ha, ondaydı sanki. Siz mail atacağım demiştiniz. Okay, okay, let's continue. When you make the F, it is going up 2.5. Normally, it should be 2. Did you remember chemical formula? Sodium, manganese, O2. So it means some oxygen is extra in our structure according to this model. So we don't say that this according to this one 2.5, because if your data is obtained from some synchrotron measurement, some neutron diffraction, it is better gives this data when you compare here. So we don't care about it. Yeah, we use here just focus on the lattice parameters. Okay, and if it is fitting good, it is also good. Now I will unclick here, go to sodium. Sodium is sometimes give some stupid data. You should be very careful and don't forget this value. Okay, control R.